Hello everyone, I hope you guys are doing good. So today we'll be covering another problem of our Blind 75 series, and the problem of the day would be problem 647, palindromic substring. So in this problem, we have been given a string S, and we have to return the number of palindromic substrings in it. So a string is a palindrome when it reads the same backward as forward. A substring is a contiguous sequence of characters within the string. So let's say for any string A, B, B, C, or let's say A, C, for any such string, we know we have two palindromes. One of the palindromes is A, B, B, A. This is a palindrome as it's read the same from left to right and right to left. And another palindrome that we have over here is B, B. So as we can see, they both have palindromic substring as these strings are a part of a given input string S. So in the given problem, we have to return the number of valid palindromic substring are there in our given input. So for this, what we need to know is how to check if there exists a substring that is a valid palindrome. So there could be two cases. Our input substring can have palindromes that are of even length and odd length. So we'll be discussing both of the cases. So let's say to check for odd length, what we have to do is we have to traverse our input string, let's say A, B, B, A, B, B, A, or let's say A, B, B, A, B, B, A. So as we can see, there are seven alphabets in the valid substring, that is ABBA, BBA. And yes, this is also a substring as the complete string is also a substring. So for such cases, when we have a substring of odd length, what we need to do is we have to start traversing an array, and we have to keep check of each element and consider them as the middlemost element of a valid palindrome. So if we are able to keep the check of the middlemost element of the palindrome, what we just have to do is we have to travel a position left, travel a position right, and compare these two. If these two alphabets are same, we just have to travel left again and right again and keep on comparing. And whenever these cases come out to be same and our left and the rightmost positions are inbound means the rightmost index is less than length of S and our leftmost index is greater than equal to 0, then we'll keep on adding the number of valid palindromic substrings to our count. So let's say when we are at I equals to 3, we'll come here, then we'll initialize our left and right pointers as 3, 3. And now what we'll do is we'll just move a place left, move a place right. We'll check that these both are equal and our right and left pointers are in bounds, and we'll just increment our counter or count variable. Then again, we'll move a position left, we'll move a position right. We see that these two are same, B and B. We'll again increment 1. And similarly, at the end, we'll just return the total C. So this would be the total count of the number of odd palindromic substring. Now the another case we have is number of even palindromic substring. So for the even substrings, the only change we have to put over here is we have to initialize our left and right variables as I and I plus 1. So now L and R both will be the middlemost element. Let's say for A, B, B, A, when we are at position I equals to 1, our L would be 1 and our R would be 2. So these two would be the building block of a palindromic substring, and then we'll keep on comparing the left and the adjacent right positions, and if they are the same, we'll keep on incrementing the same count variable, and at the final, when we are done with both odd length and even length, we'll return a counter variable. So let's get to the code. So the first thing we have to do is initialize our counter variable as 0. And now we'll start traversing our array. Let's say for I in range, length of S. What we'll do is, let's say for odd lengths or odd palindromic lengths, we'll just initialize our left and right pointers as I and I. Then we'll check while R is less than length of S and L is greater than equal to 0 and S of L equals S of R. Then what we'll do is we'll just increment our counter by 1. Then we'll shift our left pointer by 1 position towards the left, shift our right pointer by 1 position towards the right, and we are done with the odd cases. Now we'll move forward and consider the even cases. Again, we'll initialize our left and right pointers, but now it would be I and I plus 1. Then we'll again start looking for each of the palindromes. I can also define a function of the process of looking to the towards each of the palindrome as we are doing it repetitively, but it's fine to do it this way as well, as it's not a big chunk of code. So we'll just apply the same conditions and check if pointers are in bounds. And the value at left position is equal to the value of right position. We'll just increment our counter, decrement our left pointer, and increment our right pointer. And after the complete iteration, we'll just return a counter C. Let's check our solution. As we can see, this is a pretty efficient solution. And to discuss about the time and space complexity, the time complexity of the problem is big O of n squared, and the space complexity of our problem is big O of n. I hope you guys enjoyed the video. Thank you and have a nice day.